Good morning, everybody. I'm Ashmita. Today we'll be using NLP to build a autocorrect application. So it's a blog by Isha Foundation and it's about Navratri explained by Sadhguru. So what I did was I copied all the text, pasted it in my notepad, saved this file as Sadhguru on Navratri. This is the file name. And then I'm uploading it in my Collab. I have installed all the libraries that I'll be using to build this application. So NumPy, Pandas, regex, text distance. This basically helps us measure the similarity or the dissimilarity between two words. Word cloud is to visualize the words. And again, Matplotlib is a data visualization library. I'm opening the file. First, I'm reading the file and then I'm lowercasing all the texts in the file, and then I'm matching all the alphanumerical characters append to this list here. Okay, now I will have all the words here. So basically this is like pd.read underscore CSV. Usually if we have a data set for machine learning or something, what we do is we use the pandas library to load the file, to read the file, right? As this is a text file, I'm just loading all the words in this list. And then I'm checking the length. To see the unique words, you can use set. So there are 544 unique words out of 1,779 words. Okay, now I'm checking the frequency by importing counter from collections. So frequency words is an empty dictionary. And then I'm counting all the words. Now the key should be the word and the count should be the value. So frequency.words most common 10 words. So the has repeated 125 times, you has repeated 69 times. So this is how it goes. Now I visualized it using word cloud. I want to know the occurrence of each word. For suppose, I will relate this. In this, the is repeating 125 times. So the probability of the word the occurring in the block is a bit more than this. I'm trying to measure the occurrence. See, if you print probability of words, the word what is occurring 0.003 times. And if you see it is greater than what? It is 0.03. Now this is 0.003. That's how it goes. So basically I'm creating an empty dictionary here and then I'm printing sum of all the values, word values. These are the values. 125 plus 69 plus 64 plus 62, it will basically return again the length of words. And then I'm printing frequency underscore words keys. Keys is again this thing, guys. The U of is, that means all the words. What is Navratri, Sadhguru, this, culture, draws, it's all these are the keys. And then what I'm doing is probability of words of word. Among all these words, what is the probability of this word? Let's take, is occurring 62 times. Frequency of words of word is 62, right? 62 divided by 1,779. Let's see. 62 divided by 1,779 is equal to 0.0348. 0.0348. So that's what we are doing here, basically. So here we've defined a autocorrect function, which will take one word as an input. It will tell you the correct suggestion. This is what I'm trying to do. This is my word. I'm not spelling it properly. My autocorrect application is suggesting me all these words. So once you give the word here, I'm converting it into the lowercase. If it is in the 544 unique words, then return. It appears that your word choice is accurate, that you did not commit any spelling mistakes. If not this, then what you do is I'm creating a list. The list name is similar. For I in frequency.keys. Now what is keys here? You go up. This is the key. For every key, that is the, you, of, is, and, to, these are the keys. All the words basically. For every word in the words, I'm using Jaccard distance. Autocorrect application, this function takes one word as an input. We are matching it with the keys and we are checking for the similarity score. Whichever is most similar, display those. If you look here, Jaccard distance measures the dissimilarity between two texts. Again, not similarity, dissimilarity. So what it basically does is A intersection B by divided by A union B. Assume that you have two sets, A and B. In A, you have 1, 2, 3, 4 numbers, and in B, you have 3, 4, 5, 6. So intersection is the common values that are overlapping. Overlapping values are 3 and 4, right? 3 and 4. And then you have A union B divided by A union B. So 1, 2, 3, 4, 5, 6 is the union of A and B. They are talking about the size here. 3 and 4. 2 by 6, that is 1 by 3, which is equal to 0.33. Now, this is the dissimilarity score, it's not the similarity score. And Jaccard distance ranges from 0 to 1. 1 is completely dissimilar. If it is close to 0 or if it is 0, it is very similar. Now, if you want to see the similarity score, Jaccard distance gives you the dissimilarity score. So that's why what we do is we are subtracting it from 1. These values become, these swap. So basically 0 becomes very dissimilar, 1 becomes completely similar. So because we are trying to measure the similarity, guys, again, not the dissimilarity. That's why 1 minus. So if you check 1 minus 0.33, it will give you 0.67. So 0.67%. So A and B sets are 0.67% similar. And now what we are doing is we are creating a data frame. All these similarity scores are stored in similar. This is the list. Do this for every word in this list of words. Frequency word keys is this. Basically, this is it. And here what we are doing is we are creating a data frame from this dictionary, guys. Probability of words. This dictionary, which has keys and values. This is what the dictionary looks like. We've created a dictionary already here, and we are renaming the columns of the dictionary. We want the index column replaced by word. This is the column name. 0th column, we want the probabilities listed. DF of similarity is equal to similar, this list. Okay. So we are adding the similarity scores here. So now we have 3 columns in total, the word, and then we have probabilities, and then we have the similarities. We are returning the output here. We want our autocorrect application to match the most similar words. Ascending is equal to false is what? It means we want the similarity scores in descending order so that we will easily get the most similar word. Executing this cell. Now it has given me 5 options. First one is very similar. And the similarity scores, this is why we wanted it in descending order. So this could be creates, created, creation, creatures, or breathe. This is completely dissimilar. The score explains. Anyway, so that's the autocorrect. But if you give the right word, I've given Devi here, and it says it appears that your word choice is accurate. What if I give DEV, Dev here? Let's see. So Devi's devices, even level. These two are very dissimilar, but yeah. Okay, now I'm trying to deploy this model. So I'm going to Anaconda and I'm launching Spider here. This is the code that I've written. This is basically the same code I've written. Okay, whatever code I've written here, the same code, I'm copying it and pasting it in Spider. Here we are importing the libraries. We've created a list to extract words from this file. All this is the same thing. The actual application, web application starts from here. So def main in Streamlit applications def main and these 1 and 2. This is the entry point. This is where you're telling the Streamlit application that start from here. So def main is like a container, and if name is equal to main, what this is basically doing is whatever is there in this container, execute it. That's what it's basically doing. Okay, so the title name is autocorrect application, and then we are getting the user input, guys. Here, once the user enters a line, if user input, so there's a loop here. words is equal to user input dot split. So we are splitting the words. Okay, we are creating an empty list suggestions, and this is again for this to suggest these words. Suggestions for word in words, if word dot lower, not in unique words. This is the same logic we tried to implement here in this autocorrect application. If word dot lower, if it's not in unique words, then suggestions dot append autocorrect of word. Autocorrect is the function we've defined here. What this does is basically it again calculates the similarity scores and gives you the similar words, 5 similar words. Suggestions dot append, we are appending it. We've created an empty list, word in words, for every word in all the words. If we are converting it into lowercase, if that is not in unique words, then what you do is apply this autocorrect function and get the top 5 suggestions. And then if length of suggestions is greater than 0, the suggestions will only come when the input is wrong. When it's wrong, st.write, did you mean, and write the suggestions below. Else, you write no misspelled words. I'm saving this in my folder as autocorrect webapp.py. If you run this, go to Anaconda, environments, select the environment you're working with, open the terminal. Now you have to write a command. Write streamlit space run and copy the path of your file. This. So what I'm doing is I'm copying it as a path, okay, and then I'm pasting it here. Now we will change all the backslash to the front slash just for Streamlit and Python to not have any parsing errors. Yeah. So once this is done, enter. And it will open a web page for you. Here, what you can do is you can write a line. For example, let's open the text. I am taking this line, okay? These first 9 days of the lunar cycle are considered feminine. So the first one is feminine, reminded, remain, female, in. So obviously, this is the right choice. That's about it, guys. That's how you basically design an autocorrect application. Thank you.